Hey Stats class, I only have this one homework problem in the 6.3 homework set just to show you the idea of the sampling distribution and the distribution of sample proportions in this case. So let's just kind of go through this one together and just work it together. This is our population, okay? So we got 3, 5, and 10. That's our population. And these samples of size 2 are taken. So we randomly take samples of size 2 from this population. So these are the different samples that we can get. So we get 3 for the first child, 3 with the second, and then 3 with the first, 5 with the second, and then 3 with the first, 10 with the second. So it's a duplicate. I grab the first child both times. It's like sampling with replacement. So we put the 3 in there, we draw, and they have the 3 available to draw again. So it's going to be this 3, 5, 10 over and over again. We're going to do it every time, with the first being 3, then the first being 5, then the first being 10. So we get 3, 3, 3, 5, 3, 10. Reset. Now 5 takes the first, this one takes the first position. 5, 3, 5, 5, 5, 10. And now the 10 takes the first position. 10, 3, 10, 5, 10, 10. So that's the idea of this. Now it wants to know what is the proportion of even numbers for the population, the 3, 5, and 10. Well, that is, there's odd, odd, even. So the proportion that's even is a third, 1 out of 3. Now it tells me to round to 3 decimal places, so that's going to be a third, 0.33 repeating forever. But there it is to 3 decimal places. So that's how many of the population of just these 3, 5, and 10 are even. Now, if I do, these are samples of size 2. I'm going to do p hat. That's the sample proportion that is even. And that's not even, neither one of those are even. Neither one of those are even. Now half are even. So there's a 3 and a 10. 10 is even. All right, none of those are even. None of those are even. Half are even. All right, half are even. Half are even. And then 100% is even, because 10 is even both times. So these are my this is the distribution of sample proportions there. They're all there. Now what we do here is we select the smallest number we see, then the middle number, and then the largest. So the smallest is 0. The middle number that I see in the p hat column is a half, and then the largest number I see in the p hat column is 1. Now you can count it, but there are 9 values here. 3 times 3 is 9, so 9 values. And if I count how many are zeros, there's 1, 2, 3, 4 zeros. So 4 out of 9 are 0. Right, how many halves are there? There's 1, 2, 3, 4 that are halves, so 4 out of 9. And then how many wholes are there? Ones, there's just the 1. So that would be 1 out of 9. And you can see that this is 4 ninths, and 1 ninth. If you add that up, you get 9 ninths. You get 100%. So that's the population of sample proportions. It's a population because it's all the sample proportions we could get. And now the last thing we're going to do is find the average of this column right here. So right below this, I'm going to write equals the average. All right, and then I'm going to select this first one and drag all the way down to the cell above it, the last sample proportion. And you can see I get 0.33333. Rounded to 3 decimal places, it's 333 again. And what it's asking me here at the end is are these two things even? Is the sample, the mean of the sample proportions equal to the population proportion? And they are, and that means the sample proportion is a unbiased estimator of the population proportion. That means they make very good estimators of the population proportion. So that's B. They target the proportion. You can see that they're equal. So they are going to make very good estimations of the population proportion. All right, that's what you're doing on that one. It's a weird question. I just wanted you to see you are finding, even though there's only 3 in the population, you're finding samples of size 2 and all the different proportions we could get. Now you can increase this and make the population be samples of size 5, and you're taking 3 at a time, but the numbers start to get really big. Even with just samples of size 2 from a population of 3, we get 9 possibilities. Right? It is the sample, the population size to the sample size power. So like 3 to the second power. That's the 9 that we're getting. If we did a population of 5 and we're taking 3 at a time, you can see we're already getting up into the hundreds of samples that we would need. These blow up really fast, and that's why this question only has you do it with a very small population, just so you can feasibly do the calculations in a reasonable amount of time.